day everyone, welcome to another solution walkthrough on Leetcode Simplified. I'm Alan and today we're taking a look at 3 solutions to Leetcode 326, power up 3. Given an integer n, return true if it is a power up 3, return false otherwise. With the exception of number 1, powers up 3 are positive numbers such that repeatedly dividing by 3 will eventually result in 1. For example, sum of powers of 3 are 1, 3, 9, 27, and so on. Look, by definition, 3 is formed by multiply 3 one times, so dividing 3 by 3 one time will result in 1. 9 is formed by multiply 3 two times, so dividing 9 by 3 two times will result in 1. Similarly, 27 is formed by multiply 3 three times, so dividing 27 by 3 three times will also end up with 1. We're going to explore 3 different Python solutions, iterative, recursive, and a clever mathematical trick, starting with the most straightforward and gradually moving to the most efficient. Let's start simple with the iterative solution. If n is negative or 0, it's not a power up 3. If n is 1, that's a power up 3. Otherwise, as long as n is divisible by 3, keep dividing it by 3. At the end, if the result becomes 1, return true. It is a power up 3. Because we divide by 3 repeatedly, this algorithm runs in big O of log n time. The space complexity is constant. Big O of 1 is no extra storage used. Alright, let's go ahead and submit this version. Boom! Accepted. Fantastic. This version is simple, easy to understand, directly follows the mathematical definition of powers up 3. Now, let's rewrite the same idea using recursion. First, we again check if n is negative or 0, return false. The first base case, if n equals 1, return true. The second recursive base case, if n is not divisible by 3, return false. Otherwise, recursively call the function with n divided by 3 until we hit one of the 2 base cases. Done. Same logic as the iterative version, but elegantly using recursions. Let's submit this recursive version. Finger crossed. Boom! Accepted. Terrific. The time complexity is big O of log n, same as the iterative version. However, recursion adds overhead because of the function call stack, so the space complexity is big O of log n. Still, it's good to be able to think of this problem recursively. Finally, let's see a really fast and clever approach using math. The problem constraint say n must be less than or equal 2 to the power of 31 minus 1. So we ask ourselves, what is the largest possible power of 3 that satisfies this constraint? 3 to the power of 19, because it is the largest possible power of 3 that is less than constraint 2 to the power of 31 minus 1. This means every power of 3 from 3 to the power of 0 up to 3 to the power of 19 divides 3 to the power of 19 evenly. Here is a one-liner solution based on the math we just discussed. If n is positive and divide 3 to the power of 19 evenly, n must be a power of 3. That's it. No loops, no recursion, just clever math. Alright, it's time to smash the submit button. Moment of truth. Boom! Accepted. Perfect. This one-liner runs in constant time and constant space complexity. So there you have it. 3 ways to solve Leetcode 326 power up 3. If you enjoyed this walkthrough and want to keep sharpening your problem-solving skill, check out my other video right here on the channel. I'm Alan and this was Leetcode Simplified. Thanks for joining me and I'll see you in the next one.